Hi, everyone. Welcome to the SMC Journal podcast. This is the show where we're talking about systems engineering in IT today and everything to do with modern IT, DevOps, performance engineering, site reliability, observability, and much, much more. I'm your host. Thank you for joining us today. Today, I got to warn you, we're headed to the rage. Yes, that's right. That's where I get to blather on about what I think about something, and maybe it grinds my gears, or maybe I just want to expound. And today is really the latter. I'm not going to get too mad today, but forgive me if I seem a little bit cynical that Gartner is now talking about performance engineering. Yes, that's right. A new report out called the Innovation Insight for Performance Engineering has just been released. I've read it. I'm going to share the link with you so you can read it. This is the website where you can actually go and get it, and you can read it for yourself. I thought it was very interesting. So everybody loves 5 points to be made about something, right? So I'm going to talk about 5 takeaways that I got from this report and just give my feedback on it. And I also want to hear from you towards the end of the show. Interestingly enough, one of the sponsors for this report is Micro Focus, and they are coincidentally a sponsor of this program as well. You know, Micro Focus is the makers of LoadRunner Professional Enterprise Cloud and Developer. There's a QR code you can scan, and it'll take you right to the LoadRunner family where you can learn more about them if you've never seen them. One of the market leaders in load testing today. They have the widest protocol support and the largest community in load testing, and a really good analysis engine that has really hard to beat for performance testing. They really want your feedback too. You know, as sponsors, I talk to them quite regularly, and they tell me the same thing. We want your viewers to share their feedback with you about LoadRunner. What would they like to see? And we would like them to join our community and tell our product managers and product marketing managers, you know, how can we improve the product? How can we make it better for you? So Micro Focus is interesting in hearing from you. I hope that you'll take them up on that opportunity. So let's talk about this Gartner report. The Innovation Insight for Performance Engineering. I did reach out to the authors of this document. I did not get a reply in the amount of time that I waited, but we have a show to do, so we couldn't meet the deadline and get an interview. But if you're watching, would still love to talk to you about it. Maybe we could get you on for another broadcast. So this was actually published back in October of 2021, and somehow I missed this. Micro Focus reshared it, and I thought, are you kidding me? They actually are talking about this now. Now, why do I seem a little bit cynical? Because for several years, Gartner, Forrester, IDC, they have typically taken performance testing tools like load testing tools like LoadRunner and just kind of bundled them in with all of the functional automation tools, QA, the kind of products that QA departments would use, kind of products like that. And load testing is a little bit different. And when we start talking about performance engineering, it begins to be a whole different ballgame. So I'm so glad to see that this report was released. Now, reading just the little highlighted lines here at the beginning, the summary, I guess, is there's an urgent need to fulfill the heightened user expectations, meaning we need better end user experience because we're not getting it, and performance and availability of business critical applications. You know, we've got users who need that. They need performance. To succeed in this, software engineering leaders need to develop their teams and bring their competency levels up in performance engineering to mitigate application performance risk. So you're probably, if you're in the performance space, going, yeah, that's what we kind of do, guy. And you're right. If you read this report, you've been doing this for quite some time, there are going to be quite a few duh moments here because we've known this for decades, right? But that's not who this report is for. This is for you to get and pass on to decision makers, managers, executive level, and people outside the performance realm, people who might be performance curious, people who need to know this because they need to know how awesome we actually are. And I'll dig into that as we go. So what are some of the things that I got out of this report that I can kind of expound on? And again, some of these are duh, but the first one is the lack of skill sets out in the industry. And I know this is IT industry wide, but in performance, it's so bad. There is a gross lack of performance engineering skills, not just testing skills. We'll talk about testing in a moment, but in the industry, we have this lack of context around how to address performance issues outside of code, outside of the database, outside of the network. In other words, all of it, right? Companies are going to need to invest in their teams, upskill them, and educate them so that they can tackle the hard problems before them that may exist after deployment of the code and after testing and checking was actually done. That requires systems engineering and performance engineering specifically. Now, with all the churn that's happened in the last 2 to 3 years, we've had those skill sets kind of walk out, maybe to go to another company who's just paying more, or maybe it's just a better cultural fit for them. Nevertheless, you've got to replace those skill sets. And I find that a performance engineer is more of a well-rounded skill set. In other words, this is a person who could probably build their own hardware. They could probably run their own virtualization server, and they understand the cloud. They can write a little bit of code. They understand how databases work. They know how to network. They know all of this. They don't necessarily have to be an expert in everything, but they understand how the whole puzzle works together, and their focus is finding out where those bottlenecks and where those weakest links are. So that is really lacking. I heard about a conversation, keep it very general, where a very good developer in the company needed some remote support, and they were basically famous in the company for writing great code. But when they needed support, they needed somebody to access their system. So the support personnel said, great, let me connect to your system. Give me your IP address. And they said 192.168.1. something. Okay, those of you already in the know, you're already laughing at the joke. That was their internal machine on their internal network, and there was no way that remote support person could get in through their firewall or through their internal network with that IP address. They would need the external facing IP address. That developer didn't know that. Developer, should they know that? I mean, I would think they would if they're in IT, but a systems engineer not only would know why that's a problem, they probably could write some of that JavaScript too. Maybe not as well as that developer could, but they understand how that code is being written and how it gets to that GitHub repo before it gets deployed out to everywhere else. So for that reason, we get to the next point of what I learned out of this report. Developers are not always the answer to hard performance issues. Yes, they may be very skilled in what they do, and they may be able to address performance issues with their features and functions, with their lines of code that they're writing. But what happens if it's outside of their realm? Should they even care? I would say no. I would say that's what a performance engineer is for. Now, what we've done recently, recent years, through this DevOps cultures that we're building is self-service, self-support, self-sufficiency. Developers can do everything. They can build their own environments, write all the code for their environments, deploy the stuff from their environments, test their own environments, and they're responsible for everything. I think that's kind of a mistake, because what we're seeing is the burnout rate, not only in developers, but now with the site reliability engineers. You have to know all things and be very well versed in how to fix all things. I just don't think that's possible. And we're getting this cognitive overload happening in both sets of these people. So we're seeing these burnout rates between really good developers and really good SREs. And I think that's just because we're not, whatever you call the titles, performance still has to be addressed in all these different areas. And when you just say, well, you're responsible, whatever your title is, for performance, well, that's a big thing. Well, I can do some performance testing. Well, but that didn't solve our issue. And thus the frustration level at the decision maker level or the executive level says, we're testing this stuff. Why aren't we finding this stuff? Why are we still having these problems with the performance in production? Well, it gets back to these skill sets and that they're specialized, and developers can't always be the answer or the solution providers for that. So what about performance testers? Well, you'll be surprised that the third thing that I found out about this report is performance testing isn't always the solution either. And just because you have a set of tools doesn't mean those are the answer as well. Now, you've heard me talk about that before, in that if you're just a tool jockey, if you really understand a load testing tool, but all you're doing is providing test results to another team for them to figure out what to do with the problem, how much value are you really providing, right? If we can make the tool simpler, we may not need you. Then we put more cognitive load on a developer. We'll just do it ourselves, right? This is why I really feel like performance engineering is this thread that gets weaved throughout the SDLC, and it's much bigger than just performance testing the code. It's what happens on the network layer, what happens once it gets outside of our network. What about that last mile? The end user experience should always be in the forefront mind of a performance engineer. So let me stop for just 1 second here and say the biggest difference between a performance engineer and a performance tester, I think, is very simple. Performance engineers would say, testing is one discipline and one thing that I do, but it may not be the thing that I do that solves your performance problem. I've been to companies where I've been able to solve a few problems before we ever ran a single test by simply opening up the browser, going into DevTools, looking at some information and go, what the heck are you people doing here? This is the easy fix. I've seen this before on this same stack. Do this. Let's change this. Let's make some tuning and some tweaking. Performance testing would just validate what you already know in those cases. Does that mean you don't need to do performance testing? Absolutely not. You still need to do that, but it's not always the first answer to these problems. What is the next thing? Well, this is something that I've been talking about at least since 2018, and I felt like I was late to the party, but now becoming more critical than ever. Continuous performance has to be the only way that we go forward in today's modern IT, the way that applications are being developed and deployed. Now, what do I mean by continuous performance? That means that whole shifting left we've been talking about for years, the amount of performance testing scoped properly in the early stages where developers are checking for functional defects as well as performance and operational defects like security, performance, etc. Those should be built into the types of checks that are done in a continuous integration and continuous deployment pipeline. Now, it doesn't replace the need for integration testing outside the pipeline where we're looking at the whole picture here, and there's additional tests that may be done outside of those checks. But this early feedback and often feedback will catch a lot of stuff, and so that it makes the integrated testing a much easier exercise. And when we talk about just checking the box, it becomes more of a checkbox activity the more that you find earlier in the life cycle. So we have to treat performance as a continuous check and a continuous rotating wheel, the way that we are now treating development as that continuous rolling wheel process. So if you're not doing continuous integration or continuous performance and continuous integration, you should be doing it. And this is something that as I talk to many of the tool vendors and many of the practitioners out there, that's one of the biggest things that they're struggling with. I propose that the tool vendors make it as easy as possible by making your tool easy to integrate in the pipeline, making sure your documentation is really clear, and maybe providing some training, whether that's just a formal class or just some online videos or something. The more you have, the better. We can't have enough information. Make it easy for companies to adopt performance earlier in the life cycle, and they will do it because they'll see the value of it. So, what's the last thing that I found? Well, it's not really a discovery, it's more of a thank you. And that is a thank you to Gartner for actually producing this report. And so I'm just going to be like Oliver Twist. Please, sir, can I have some more? From Forrester, IDC, and other places like that, would you please produce more information around performance engineering and how it's important in the entire landscape of enterprise IT, and not just enterprise, but all companies, small, medium, or large. Here's my thought about this. My question now is that you've acknowledged that it's important. When do we get to sit at the big boys table, right? We should be the CIO's and the CTO's best friend, the performance engineer. Why? Because we want the same thing they want. They want fast, resilient, efficient, read that as low cost, and low risk deployed applications in production. That's kind of what we do that's our job description to do on a daily basis. So why aren't we the ones getting our photo taken selfies with the executive levels? And why aren't we the unicorns and the rock stars that they're talking about instead of just the full scale whatever developers, right? Full stack developers. We should be those ones. That's my. Now, some people would say, well, yeah, but the developers, they are rock stars. They're the creators of all these great functions and features that we use every day. Well, to some of us, they're just defect incubators. Well, I know that's a pretty harsh thing to say, but hey, maybe it generates a little bit of feedback. What do you think about this? I love this report. I want to hear what you think about this and my commentary as well. You can find me on several different platforms, including LinkedIn, Twitter, Instagram. You can go to the smcjournal.com. You can scan that QR code and it'll take you to a page that's got all the links of where you can find me. I'm pretty easy to find. And if by no other means, you can write me at my new email address, heyscott@smcjournal.com, and say, hey, Scott, this is what I think. And I would really like to know additional topics we could talk about, even outside performance engineering, on this show this year. Who should we interview? What kinds of things should we be discussing? And if you like this content, you can really help me train that freaking YouTube algorithm to go to get more eyeballs on this content, because I think the content's good. And you're telling me you like the content. Let's get people to subscribe and see this content out there. There's a link to the page, the short link, and a QR code take you right there to it. Would love to hear your feedback about that. So, for this episode of the SMC Journal podcast, thank you for watching. We'll see you next time. Bye-bye.